Hey guys, welcome back. So, I got a Husky generator here, and this one actually I already did a video on. It had fuel issues, of course. I think there was water in the fuel. Carb was a mess, typical story there. And there was some rust issues. I painted up this plate here, as well as the exhaust system, and just, I think, replaced the air filter. So that was really all it needed. And anyway, that was about a month ago is when I fixed this. Fast forward a bit, a week ago I sold this to a contractor, and he used it for a couple days and then it stopped making power. So, he reached out, asked if I warranty my stuff, and I've never been asked that before, but I guess I do because it's back here. In that video, that first video, I did do an ohms test on this one, and it was 0.4, 0.5, and I did pull that cover off of the gen head, and the copper looked excellent in there. So, I don't know what it's gonna look like now, but I'm gonna get you set up in a stand, and we're gonna run some ohms tests on those outlets and pull that cover off the gen head and see what it looks like now. Okay, so I got the meter set to ohms, and if you're doing this test, you do want to check the resistance of your meter first. In this case, I think this meter is 0.1. So any reading I get, I can subtract 0.1 from it. Point 0.4, 0.5. That's good. That's exactly what it was before we had this power problem. We'll check the other side. Okay, good. So both 120 legs on the stator are at 0.4, 0.5. That's exactly what it was a month ago before this guy had it. So let me get the cover off the power head and see what that looks like. Okay, so let's see what the carnage is. So what do you think? It's gonna be crispy in here? Stator still looks good. No broken ropes, wires good, color. And the rotor, again, not that you can see much of it, but there's no obvious sign of a meltdown here, so that's good. We already tested the stator ohms, and the stator itself visually looks good, so I'm leaning away from it being a stator problem. Most likely it's an AVR, brushes, or I guess that's it, AVR brushes. This rotor has permanent magnets on it, so residual magnetism shouldn't be an issue. Let me get the wires here off the brushes and get the resistance reading through the brushes into the rotor. Okay, so I got the meter set up on ohms again. I'm just gonna put each lead on each of the terminals for the brushes and get a reading. A healthy rotor should test between 40 and 70 ohms on this generator. Okay, well there's our problem. I get a big fat 0. So, either the brushes are bad or something with the rotor. So, I'm gonna pull those brushes and get a better look. Wow. Just dodged a bullet on this one. These brushes are trash. Well, specifically that brush. This one looks good still. So I am not sure what came first here. Did it arc, overheat, and cause the plastic to melt, and ultimately the brush to, it looks like, chip? Or did it chip, causing the arcing and then the melting? I don't know, but this is kind of the best case scenario. These are like $5, and I think I have an extra set of brushes, so let me grab those, we'll pop them in, and test the ohms again. All right, so this is what I came up with. I do have an extra set of brushes on the left. You can see they're both there and in the correct position. These brushes are a little bit more worn than the broken ones, but it's all I have at the moment. So I'm going to install this, do another ohms test, and bring it outside and just make sure that everything's good. So actually, before I put the new brushes on, you can kind of see the slip rings are dirty, especially the one here closest to the end housing. So I'm going to try to clean that up a bit with just some green Scotch-Brite. The one thing you do have to be careful of, though, when you're doing this, especially when everything's installed, is that you don't want to bump that wire terminal. You can kind of see it right there, because if you do, you could break it, and then the rotor is really trash. So make sure you don't bump that. There's actually one terminal going to each slip ring. All right, so this is what it's looking like after a few minutes of cleaning. You know, I've gone all around the slip rings once. I'm gonna do that again one more time, and then put the new used brushes on there and see what we get. Okay, that's pretty much it. You can tighten this with a wrench if you want, but I tell you from experience, there's only one bolt holding this in, and it strips out really easily. So I would do it very lightly. You're better off to have it loosen up than the alternative. All right, I'm not doing it anymore. I get this set to 20 inch-pounds. It's making me nervous. Just snug it up. That's all you need. All right, hopefully you can see that meter. I'm gonna do another ohms test through these used brushes. Again, a healthy reading should be between 40 and 70. And we get about 60, so that's good. So this thing should make power now. I'm just gonna reconnect these two wires. Red goes on the left. That is how the wires go on to the brushes. All right, as you can probably see, it's drizzling out here a little bit. So I want to make this test quick. Just want to start it up, make sure that light turns on, and then I think we're done. Okay, good. Really dodged a bullet on this one. It was just the brushes, thankfully. And if your generator's not making power, it's not always terminal. Make sure you check the AVR and brushes, as well as do the ohms test on the stator and rotor. You know, in this case, it was a $4 part, so got lucky on this one. Anyway, hope this video helps someone. Thanks for watching.